Welcome to Supercool, the show tracking the rise of the low-carbon economy, a multi-trillion-dollar transformation reshaping global industries. Each week on Supercool, we spotlight the climate technologies, business models, and strategies already cutting emissions, boosting profits, and improving modern life. I'm your host, Josh Dorfman. If you're enjoying the show, please subscribe or leave a review wherever you listen. According to the U.S. Bureau of Labor Statistics, employees switch jobs every 3.9 years. It's even shorter for younger employees, those in their 20s and 30s, who tend to move between companies in search of that perfect fit, better salary, or a corporate mission more aligned with their values. Tim Holt, on the other hand, has been with Siemens Energy for 30 years, his entire career. That's 7 career pivots he never made. Yet when you talk to him about Siemens Energy, he lights up. He'll tell you he's never had a boring day. And that's because for 3 decades, he's been building businesses that power the world. Turbines that run hotter than their melting point, wind turbine blades the size of football fields, hydrogen technologies engineered to run on renewables. For Tim, it never gets old because it's always new, constantly evolving, and always big. Siemens Energy is an industrial power giant, one of a handful of companies that actually make the world work. About 1/6 of all electricity generated worldwide is powered by Siemens Energy technologies. Tim has been CEO of its wind and renewable energy services, CEO of Siemens Power Generation Services, and Chief Operating Officer of Siemens Gas and Power. Today, he oversees the grid technologies business and the Americas region for Siemens Energy. He's also a member of the executive board and its labor director. So when it comes to energy and the power grid, Tim sits right where the action is, and the action is heating up. That's why he's not leaving his posts anytime soon. So, what's the big deal about the power grid? As Tim told me, it took the modern world 150 years to build the power grid we have today. Now, we have to build that much capacity again in just 15 years, and then do it again in the 15 years after that. That's turned what was once a sleepy corner of the energy sector into one of the most dynamic industries on Earth. What Siemens Energy is building today gives new meaning to big tech. This is big infrastructure, built to move our modern world into the low-carbon future. Here's my conversation with Tim. Tim, welcome to Supercool.
Thanks, Josh, for having me on Supercool.
Your career at Siemens Energy has spanned, from what I can tell, so much of the company. So why don't we start there? Give us a brief overview of Siemens Energy, the U.S. operations in particular would be interesting, and then a little bit more about your background as well at the company.
As you know, Siemens Energy, we're a young and old company. We're part of Siemens, over 180 years old, but also very young because we did a spin-off, similar to what we've seen with other companies in 2000. So you could say Siemens Energy as an own company listed exists a little under 5 years, but with a long heritage, always in electrification. And our focus is on energy and also being the technology leader in the energy transition. And we do that focusing on 3 strategic pillars. We say zero or low carbon generation. That's our wind portfolio on and offshore, but also the gas portfolio, which we see as a transition technology. Can also do cool things with gas turbines running on hydrogen, carbon capture and storage. So I think there's a good pathway there to get to net zero. Then the second big strategic pillar that we have is transportation and storage, which is our grid business. Independent how you generate the electrons, you always need to move them from A to B and also potentially store them to use them when the sun is not shining, when the wind is not blowing. And then the third strategic pillar is what we call decarbonization of industries. How do we take the carbon out of steel, out of cement? And in terms of portfolio, we look at hydrogen, have an electrolyzer business, compression. We do industrial steam. We do electrification, automation, digitization of industries. So all 3 pillars pay into the energy transition. And I can say I've been with the company 30 years and I've seen everything. I worked in gas turbines. I worked on the wind side. Now I worked on transmission. We did the carve out. I was having the hydrogen business for a short while. So I've seen every technology. When I started 30 years ago, was a time when wind just started. Solar was really far, far away. And I always said, you know what? I start with gas turbines. That's probably how I retire because that's the technology to be. Those solar panels, wind turbines, nice, a hobby, but that's never going to be mainstream. And I guess I learned in the 30 years you can be wrong a lot of times when you have a technology outlook. Glad to see how wind and solar came into the picture. And now I think we have everything, and that makes the industry and the last 30 years so exciting.
Yeah, just to hear you talk about it, all of those are themes we discuss on Supercool. So essentially, you've been doing all the fun stuff, which
Yeah.
which because I was going to say 30 years at one company is not quite as common today as perhaps in,
Yeah.
times past. You're describing what you've been involved in. Is
Yeah.
what has inspired you and kept you motivated to be there?
My background is aerospace engineering, and somehow instead of building planes, I said, "How do you power planes?" And that's how I came to the gas turbines. First of all, what fascinates me is the technology, and I mean we're spending over 1 billion each year in R&D. If you look, these gas turbines, they run at temperatures where the metal melts, and really complex castings. You have to protect the blades from melting, thermal barrier coating. Then over the time, as wind became more prominent, you look at these wind turbines. Nowadays, the blades are over 100 meters or so, over 300 feet tall. And you see these really massive structures and the engineering behind it. Then hydrogen came on, kind of focused on mechanical, on electrical. All of a sudden, the chemical comes into it and green power and doing electrolyzers. So I think over time, there's so much technology shift in the industry, and at the same time you work with the same customers. And some of them I knew were young engineers, kind of ruffled our feathers, and now they're also executive. And you look back and you look at just the industry and what we mastered. And we had our ups and downs. We saw the boom cycles, we saw the bust cycles, we worked through restructuring, technology problems, and I never had a boring day at the company. I never woke up in the morning and said, "Oh, I don't want to go to work." Maybe you heard it. I just find it fascinating.
It's so interesting, Tim, because I'm talking to you now, 2025, and you've been in these industries for 30 years. And so you've seen all of this technological innovation. Just preparing to talk to you, I was looking at some recent headlines around Siemens Energy, and you see what's come online, an offshore wind turbine in Europe, certainly the largest European wind turbine ever built, meant to try and compete against the Chinese, or at least it's framed that way. Massive scale, unbelievable scale. And it's almost incomprehensible how big that span is, that diameter of the blades. And then I'm reading about, and I think this maybe is in Norway, a carbon capture project, and all of these technologies that are of the moment, that are so exciting. And you've been seeing all these technologies of the moment for 30 years, and now it's just these are the ones today as we're talking about decarbonization and electrification and really trying to move the world in the direction it needs to go. So I could see how it's endlessly fascinating in that way.
I give you an example. Last week, there was a big European wind fair. I was flying into Denmark, and you might know we built the first offshore wind project in Denmark off the coast of Copenhagen. Very small turbines. I believe they were under 1 megawatt, and there were 13 very near shore. I mean, you could also swim to the turbine, so it's not the offshore you see 50 miles. But those were the first. Landing, I always looked out of the window to see how they're doing, and I didn't see them. And I was talking to a colleague. He said, "Yeah, it wasn't only the first offshore project that got built, it was also the first offshore project that actually got dismantled." So even in the technology cycle, young technology, less than 100 feet tall, and now you see the new structures that are 600 plus feet tall, and just the technology evolved. You also see the cycle, and even in the new technology, you see how that's being pushed and getting into new cycles, bigger, more powerful, more efficient. The technology push is ongoing.
And now I'm reading about a Siemens Energy factory in the US that is doing some very innovative work around recycling rare earth minerals. As we've looked at the US and we've looked at electrification, more energy needs to come online. Transmission is something that is talked about, but not quite as much as in terms of, okay, if we have electrification, we have AI, we have data centers, we have extreme weather that's actually causing more energy to be used, heating, cooling, whatever the situation may be. There's attention on it, but there's less focus on the grid itself. You have to build generation, then you have to move it, right? And so you've said that we've effectively built a third of the future grid. Can you talk me through what you mean by that, what needs to be done, and how you see this unfolding?
I'm glad you mentioned it because a lot of times we talk about energy transition. We always talk about generation, more wind, more solar. We talk about green hydrogen, but we always forget at the end, each electron has to move from A to B. And maybe it's not so exciting to talk about wires and substations, but it's essential, right? And I think up to even 15 years ago, I think the grid was taken for granted. People didn't expect much of an upgrade expansion. There's certain utility CEOs that even quoted in 2010 said, we can take all this renewable, we don't need to build out the grid. The grid is sufficient. That same utility has now announced a multi-billion-dollar capex expansion to expand the grid. So it shows you also over time how that has evolved. Couple of statistics just to put it into perspective. We all know that electricity demand is going to grow 4% annually going forward. We say electricity demand is going to more than double by 2050. There's a statistic that said what we spend in the US on the grid in the last 150 years, the same amount we need to spend in the next 15 years, and that same amount the 15 years thereafter. It just shows the massive need for investment. Plus, you look at renewables, and they said generation is going to increase sixfold globally. So that also puts a lot of strain on the grid. And where does it come from? First of all, as we said, it's fairly old, the grid. A large portion is greater than 20 years old. There's always the joke, how long is a transformer going to last? One more year. But you can only say that so many times, and then at one point it's like, okay, it's really end of life. So we have this massive investment need, plus the expansion. Data centers is one, the big renewable winds in the Midwest, how to bring it to the load, all the solar that needs to get connected. And with more renewables on the grid, of course, you have to keep the grid stable. I mean, you want this nice, even frequency, no flickering of the lights. So we need also technology to keep the grid stable. So all in all, that really translate into this huge investment needs, and we have seen it. Our customers that I talk to, US but also globally, most of them have more than doubled or tripled their investment on the grid side. The public utilities in the US, if you look at their capex spend when they publish it, a larger and larger portion goes onto the grid. It might seem boring, but I think there's also a lot of cool technology on that side.
Let's dig into some technology and some of the business lines of Siemens Energy.
Mhm.
You talk about things like synchronous condensers. Nobody knows what that is, but yet what I find fascinating, the reason why I want to talk to you about it is because there's really no zero carbon future without some of these technologies that are really like the guts
Mhm.
of decarb in some ways. Can you share some insight there, like your product lines, how they
Yeah.
work, who you're selling to?
I mean, of course, there's the classical products that you see on the substation when you drive by the highway. You see a lot of cables going in, some equipment that's really transformers and switchgear. The electrons come at a certain power level and then get stepped down, so it gets distributed, or stepped up so you can transport it over a longer period. And then, of course, that's the basic technology that you see throughout the US. You have 385 kV for the long distance, and then once you get into the cities, you go to the distribution level, 66 kV or lower. That basically brings it, and then you step down, and then you have the little bucket transformers that you see on some of the overhead lines in your neighborhood that really step it down so you can use it in your house or in the neighborhood. And then there's actually technology that keeps the grid stable. Of course, the more you have wind, the more you have solar, and you take old coal stations, old gas stations, in some parts of the world, nuclear power stations out. What's missing is that baseload power. And all these generations, what they have in common, they have a large turbine that creates a rotating mass. And if there's more demand on the grid and the frequency drops a little, you can always tell them turn a little bit faster and then keep the frequency stable. Now that we move to a more renewable world, what's going to happen? You take these turbines out and you have wind turbines, you have solar power, and you're missing these large rotating masses that keep the grid stable. And that's where you need some technology to compensate for it. And that's basically what we call a synchronous condenser. A large generator that's spinning, and if needed, if the frequency drops below 60, it goes to like 49.99, You need to bring it up to 60 so that we have this nice even frequency throughout the grid. So those technologies you will see more and more as older large power stations retire, and you have more solar, you have more renewable in the system, which doesn't provide that, and that's basically the technology we have. The other
Hmm.
cool technology that we have is what's called HVDC, high voltage direct current. And it's basically, how do you transport power electrons over long distances without a loss? And there's two ways. You can have long AC lines, but the losses go up exponentially the longer the line. And that's why what we've seen to connect offshore grid, for example, in Europe, also long distance power transport in the Midwest. We have a lot of, in the past, a lot of coal stations, now wind. Load centers are on the coast, long HVDC lines to bring the power there without losses. So those are kind of two really cool technologies that people don't know a lot about.
Thank you for walking me through that. Let's stay on the first for a second, and synchronous condensers and stabilizing the grid. We
Mhm.
hear a lot about storage, and we
Mhm.
hear, okay, there's more grid scale storage batteries coming onto the grid. What you hear is,
Mhm.
okay, yes, this helps capture intermittent sources
Mhm.
of energy, wind, solar, but you also hear that this helps with grid stabilization. But
Mhm.
and so the answer is probably yes, but it sounds like it's yes, and you also need other technologies that are enabling grid stabilization. Is that the right way to think about it?
Correct. One is to have an even load flow, how much you put through it, and then at
Yeah.
what frequency you put through it. And then if you have a lot of demand, batteries can put some in it, but it's also a question of how fast can you stabilize it? How long does it take until the battery starts discharging and gets on the grid? I think it's also a combination. And we at Siemens Energy have one project actually in Ireland, and especially on smaller grids on islands, it's even more important where we combine the storage together with the grid stabilization, and we do it there through power electronics. So the battery is doing one part, but then you also have power electronics that do the other part, that do basically modulate the frequency. So there's also storage together with the power electronic version of grid stabilization instead of a big rotating mass. That also works. So there's different ways you can do it, how you achieve it, and it depends, is there enough power to charge the batteries? And it depends a bit on the system design and what works best for that particular part of the grid.
We talk to a lot of companies that are, the only companies that we talk to are beyond pilot scale or
Mhm.
commercializing technologies. Often that tends to be growth stage startups, some public companies. We've had on Mary Powell, the CEO of Sunrun recently. But when I think about the trillions of dollars that are actually now being invested globally in the
Mhm.
clean energy
Mhm.
transition, think
Mhm.
about the scale of what needs to take place. It's really, I guess the thought that's going through my head is it's imperative that Siemens Energy not just be at the table, but keep innovating. So, how do you think about your culture and staying on the cutting edge of what everyone's looking for? You have this massive scale. How do you stay innovative?
I wouldn't call it a paradox, but you have to balance both sides. Even our customers are very conservative. I mean, what is the main purpose of the utility? Making sure if you flip the light switch, if you have a factory, the power is stable, reliable, that people can basically trust you. Reliability is kind of the number one focus area. And sometimes I say if you focus too much on having that secure supply, you ignore innovation because innovation is always risk. It's like you put something new in, is it going to work? And I always say, does a utility CEO get fired because he is not innovative enough, or does he get fired because the power is gone for 2 hours, right? And so there's a certain risk awareness in the industry. At the same time, and I think this is also the time I've seen in the industry, because of that massive need, what you do or what you have done in the past doesn't get you to the future. And it's also not affordable. All of a sudden, we look at, okay, we have all these assets. Yes, with the need, we can add more substations, more lines, and so on. But at the end, somebody has to pay for it. So let's take a step back and let's look, are we using what we have in the most efficient way? And I think that's where a lot of the startups or the young companies you talk with, they see the potential. That's where we see the potential. Digital grid, right? How do we get more electrons through the same lines, through the same substations? And it goes a little bit back what I said. In a conservative industry, you design everything with a certain safety margin. It's like your car. I mean, even the tank shows empty. There's still some miles in it that you can drive until you get to the next gas station, even though it shows you empty. If we say at this time the grid is at the limit, you probably can still put more through it, but you also have to know what that means. And that's why we see also a lot of companies put more sensors on the transformers, on the switch gears to say, okay, how is it really operating? What does it do? Substation automation. How do I work and get more through the lines and through the substations? And then at the end, it's a software on top. How do I control that? And I compare it very much to the self-driving cars. Where does it start? First, you have the sensors that measures the distance to the car in front of you, all the different sensors that you need in order to have that autonomous driving. The next is really the software that sits in these sensors and what does it do to the car. And then at the end, you have the software on top that actually steers the car. And we have a similar vision that we say the grid could be the same. Could we have a self-driving grid that regulates and says, okay, I don't need to control the wind turbines because I get the extra power, put it to the system, I operate on a 10% overload, but with the software I can direct the flows. And that's the innovation that we also push in our company and my organization in terms of saying, look, we still need this product, very traditional, needs to be reliable, needs to meet what our customers need. At the same time, we need to add features, functions, and add-ons that enable that traditional piece of equipment to even operate beyond its limits, but we need to know what it does and how we can do it safely and securely.
So a lot of that is about taking what exists today. How do we take what exists today
Hmm.
on the infrastructure and get more out of it? We also know that we're going to have to build a lot more. As you said, we've built a third of the future grid. So if we have to build in the next 15 years what we built over the last 150, and then we have to build that again
Hmm.
15 years after that to get to 2030. Are we building today, or is Siemens Energy what you're delivering to your customers? I'm imagining you're delivering what has been planned already for years. As you say, these are conservative industries,
Hmm.
and the most important thing is stability,
Hmm.
planning. Can you give me some insight into that process? Because I read also that you were at CERAWeek down in Houston at the conference
Hmm.
last month, and the conversation came up around gas turbines. And there's only
Hmm.
now a handful of companies in the world, like Siemens Energy, that
Yeah.
make these industrial turbines. And the pipeline's pretty full. So if someone calls up and like, hey, I want a turbine, it's like, oh, okay, we'll see you in 2029. Yet
Hmm.
we know we have all of this surging energy demand too, as you've mentioned. So what is that planning process like for Siemens Energy? I know nobody wants to get too far in front of their skis, so to speak, and be investing and not
Yeah.
quite know, like over investing, right? So what is that planning process like for you and with your customers, and how do you handle that?
It has been a wild ride the last 3 years. And we traditionally come from an industry, as I said earlier, the transformer is going to last another year, 1%, 2% growth rate, so very stable, enough capacity. And then with all this energy transition, something needs to change. And everybody agreed, yeah, something needs to change, but it never happened. So utilities have this 6 years planning cycle. I said, okay, I need to do so many replacements, very conservative. And I wasn't calling it a sleepy industry, but the blood pressure was fairly stable, let's put it this way. And then a couple things came together. We had COVID, where people said, oh, we don't know what's going to happen. Maybe we don't do the investments. We postpone another year. We had the war in Ukraine, which also in Europe kind of pushed a bit. How do we do energy security? Maybe we need to push the renewable targets a bit faster. And then, of course, net zero targets and regulators got more serious about how do we really do the build out on the renewable system. And then all of a sudden, somebody started to order. And of course, we had issues also with our suppliers, and delivery times got longer. And it was kind of the toilet paper moment of the industry. You go to a store, you see empty shelves. The next time you see some, you grab it and let's grab more than I need. And all of a sudden, everybody got wild in terms of, okay, let's make sure I have enough inventory for the next years. We know supply chain is disrupted. And I also had the discussion with my sales team. At first, it was like, oh, everybody's panic buying. And then we said, okay, panic buying, let's make sure we work on it. But I don't need to add a lot of capacity because at one point it's going to normalize. Then something happened. And I think it was also the whole push to people are really investing, people more modernization, exchanges. And it started to happen. And out of this panic buying, it kind of shifted. This is a full swing on the energy transition. And that's, of course, where we said, this is not going back. The demand is still there, and we don't have enough capacity in the market. And that's when we looked, okay, how do we expand capacity? And, we operate a network of 43 factories. And what we did is, okay, let's get more people, let's increase the number of shifts. I mean, let's churn more out. But very soon you're at the limit, and it's like, okay, we're now having, every shift staffed, but we're still not getting enough out because there's certain bottlenecks in the factory. I mean, you have a test bed. At the end, if you only have one test bed, you only get so many transformers or switch gears through the test bed. So we said, okay, let's expand. Let's look at the bottlenecks in the factories and build a second test bed, get more drying ovens for these transformers or more winding machines. So that was the second step. And then we said, okay, but still not enough. And the demand is not cooling off. The energy transition in full swing started in Europe. We're going to see it in the US also with the modernization, the renewables, data centers. India's coming, Australia's coming. So this market trend that we first started as, okay, is this panic buying, has developed into a trend of kind of 10% year-on-year growth for the products and services we offer. And that's where we said, okay, now we need really the CapEx investment program. I always say at the end, we need the qualified labor. This is complex manufacturing. This is not, I just put a factory in the middle of nowhere and, hire a bunch of people and they start churning out product. Where we said, okay, if we expand in existing facilities. And that kind of evolved into a 1 billion investment program in expanding capacity just for Siemens Energy alone. We hired over 4,000 people in the last 2 years. We're going to hire another 7 to 8,000 in the next 4 to 5 years. And you see from panic buying into a full swing, this is really the market has taken off. And that's how we see also the competition getting ready. Our customers are now more into 10, 15-year planning cycles as well. They said, okay, we want to make sure we give you the transparency and outlook because we want you to invest and have that certainty. So the industry has really evolved from, okay, a very dull, low blood pressure moment into, hey, go full swing and go as fast as you can and get as much as you can online as fast as you can.
Wow, and do that around the world,
Yeah.
really all at once, like you're talking about. Yeah. You've said that one of the biggest constraints to building the future grid is talent and making sure there are enough engineers with the skill sets for what you're
Mhm.
describing. How do you see that today? Is that something that you put a lot of emphasis on, the company's constantly focused on?
Yeah, constantly. This might sound wrong, but CapEx isn't the problem to build a factory. Of all what's needed to build a factory and get it up and running to the quality that our customers want, it's not so much putting a building in and buying the machines. It's more about how do I staff it? Now, if I do large power transformers, I need 800 qualified, skilled people on the manufacturing floor that actually know what they're doing. And the degree of automation, it's not like a car assembly line where you have the robots and it's kind of repetitive work. A lot of these transformers, there's a large variance between where you build one, the next one looks different and needs a bit of a different skill set. So it's not easy, and you don't pull these people off the street. And that's true for the US, that's also in Europe, and that's skilled labor, even with the attractive salaries that we have. It's hard to get and hard to train, and it takes 3, 5 years to get them up to the level. And our customers have to have the competence. If this is a new factory, how do I make sure that the product is there? So that's where we use existing factories, expand. We have then on the shop floor, but also on the engineering side, we have a skilled person with experience that mentors a new person. We put a lot of work on apprenticeship programs where we train and educate people for 3 years, get the degrees and then start working. In the US, we work with a lot of community colleges, help them shape special courses, do internships, work in our facilities with these skilled technicians that we have. On the engineering side, the same. First of all, there aren't that many electrical engineers that graduate every year in some parts of the world. A lot of them then go into the software side, the tech side, but also attract them, work on high voltage engineering. Not that easy. But that's also where we took a global approach, where we have established certain competence hubs. We have one in India, we have one in Mexico, one in Romania, And it's more about, okay, where do we have also talent pools that we find the people that we need? There's a good balance close to the customers, but also use these competence hubs to supplement. And it's all about going out to universities and making sure people find this industry attractive. What you said earlier, nobody talks about the grid. So we need to start talking about it to attract these really young, talented people.
Yeah, that's fantastic. That's really fascinating to hear. It reminds me, before I had started Supercool, I ran a company. It was a startup with two engineers from SpaceX. And
Mhm,
so it's called Planted. We make carbon negative building material. So we grow this grass that grows very fast, kind of like bamboo. It's not, it's
mhm,
thinner, so we can mechanically harvest it. And then these SpaceX guys I started with, we do this in North Carolina. We built an entirely new production line that's electric, no smokestack.
mhm,
It's modular. It's really cool. We get the plywood. That's actually where we're locking away carbon. We recruit only engineers who build Indy race cars in
mhm.
university, and they all go up to Michigan to compete. And so my co-founder, Wada, who ran the life support systems at SpaceX, he's in Michigan, but he's there with like Tesla, SpaceX, and here we are, this little startup trying to be like, hey, come work on building materials, this like really unsexy thing that we need you to get excited about. So competition for talent deeply resonates with me.
Mhm.
And bring them to North Carolina, to a rural location. Not easy to do.
Yeah.
Uh, but yet, at the same time, Siemens Energy, what you're describing, this is the future so many young people want to be part of and want to be building. So I would imagine, a tailwind for your company in terms of recruiting.
First of all, energy is exciting. I mean, as you heard it, it's international, it's big infrastructure, there's a focus on it. And I always said, what company you have the chance also to work on so many projects across the world with so many colleagues? You work in a network with engineering colleagues in India, in Europe, in the US. You have different manufacturing plants. I'm in Spain. I'm actually going out tomorrow and watching the sail out of a large HVDC platform that's 20,000 tons of steel, 11-story building that has the technology inside that basically connects the wind farm with the shore. I mean, you see that, and you show me one student who doesn't get like really shiny eyes and looks at it and says, wow, this is cool. Because at the end, you actually see what you design, what you create, you can actually implement it, and you can tell your family at dinner, what do you do? And it's like, okay, you see the light that comes out of the light bulb or the cooked our dinner. I'm actually make sure that gets to our stove. So I think it's also, yeah, it's a good story to tell also to your family that what you do and why it matters.
If you could wave a wand, and just coming back to grid infrastructure and think about some of the issues that might be in the way. I've just heard you talk about planning and permitting and standardization and some of these challenges that the industry faces in terms of growth. If you could wave a wand and everyone's just going to listen, Tim says, and then the world changes, to go as fast as this needs to happen, what would you love to see?
I see this massive need that we have. I also see the limitation that each of us has, right? I need to invest in capacity, but I also have to be diligent to make sure, okay, I don't overinvest. The customer says, hey, I have a regulator. I don't know how long it takes. I would love to standardize, but then I have somebody who tells me, what I have to do. And the regulator will say, yeah, but with this uncertainty. Somehow, my magic wand would be, we got all the stakeholders around the table. After 1 hour, we say, this is the plan. Everybody goes away. And for the next 5 years, we just execute and we deliver what's needed. And everybody does it in the most efficient manner. And I think that's, at the end, we also want to make sure that the energy stays affordable. And we get the cost because at the interfaces, we're not completely aligned. And I think we have good ideas what we could do better. Our customers have really good ideas what they can do better. I think the regulator and politicians have to play a role. If we can just say, okay, take all our limitations away, how would we do it in an optimal manner and the most efficient system design and not just individually? That would be my one to say, okay, let's optimize the system together and then everybody does what they're good at without any limitations and boundaries that somebody else puts on them.
Appreciate that perspective. And I hope that you get your wish because I know that's
Yeah.
exactly what we need. Tim, I want to thank you so much for spending some time with me and with our audience. It was fascinating to hear your story, what Siemens Energy is doing both in the US and around the globe, and to get that real global perspective and bring that into our conversation. I really appreciate that.
And thanks, Josh, and thanks for letting me share my passion for this business. I hope this came across a bit.
Absolutely did.